Hello all. In this lecture, we are going to discuss about types of grammar. There are four types of grammars, type 3, type 2, type 1 and type 0. Type 3 grammar is otherwise called as regular grammar. There are two types of type 3 grammar, right linear grammar and left linear grammar. Right linear grammar means this is the general syntax. A variable tends to alpha b bar beta. That is, a variable tends to alpha, another variable bar beta. Here a and b are the variables, alpha and beta are the terminal symbols, any number of. So here alpha and beta may be any number of terminal symbols. So we can say that a variable tends to string of terminal symbols or string of terminals followed by a non-terminal. Actually this non-terminal can again be replaced by string of terminals followed by non-terminal, like that. Therefore at the end right side only it will be expanded. Therefore it is called as right linear grammar. In left linear grammar, a tends to b alpha. This is written in the alternatively. It is first b is written, then alpha bar beta. So here also a and b are the variables, alpha and beta are the string of terminal symbols, that is any number of terminals. So a variable tends to string of terminals or a variable tends to variable followed by string of terminals. For example, in this grammar, a tends to ab bar a and b can be expanded like this. So a can be replaced by ab or simply a. Suppose if we have to consider this production, a can be replaced by ab, then this b can be replaced by ab any number of times. Finally it should be replaced by b. Okay, so we will get it is expanded like this. Therefore it is called as right linear grammar. If we this is the example for left linear grammar. So here a variable followed by a terminal, variable followed by any number of terminals can come. Here we can write any number of terminals. This is an example grammar. So we can construct a parse tree for this, BA, 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 B. So this is an expanded like this. So this is an example for left linear grammar. So right linear grammar means string of terminals with a variable tends to string of terminals with a single non-terminal. Left linear grammar means a variable tends to a single variable followed by string of terminals. Then a mathematical model for accepting for this type of grammar is called as finite state automaton or regular expression. So regular grammars are accepted by finite state automaton or regular expression, and the language generated by this grammar is called as regular language. So this is type 3 grammar. Next one is type 2 grammar. Type 2 grammar is otherwise called as context free grammar, that is CFG. We have already discussed about context free grammar and the set of problems in the previous videos. And context free grammar means all the productions are in this form, alpha tends to beta, where alpha is a single variable. So this is not a string here. Alpha is a single variable. So the length of alpha is 1. Okay, any single variable tends to beta. Beta means any number of variables and terminals. Okay, star including epsilon. So we can, this is an example. A variable tends to a single terminal or any number of terminals and non-terminals can be combined, including epsilon. S tends to epsilon is also allowed here. And the mathematical model that accepts this grammar is called as push down automata, and the language generated by this grammar is called as context free language. And this grammar is called as context free grammar because wherever s appeared in the string, it can be replaced by the body of the production. Okay, that it won't depend upon the context. Therefore it is called as context free grammar. For example, we can derive this like this. Yes can be, yes appears here, so it can be replaced by any one of the production. And in the next step also, yes can be replaced by any one of the production. Okay, here this is the context means the nearby symbols. We don't worry about the context, the previous or following symbols. wherever s appears, it can be replaced by any one of the production, and in this step it can be replaced by as, and this s can be replaced by a. Okay, therefore it is called as context free, but context sensitive grammar means we will consider the context also. Then type 1 grammar is otherwise called as context sensitive grammar, CSG. Here also all the productions are in this form, alpha tends to beta, where both alpha and beta are one or more variables and non-terminal variables or terminals. So epsilon production is not allowed here, okay, because beta should be at least one non-terminal, at least one variable or terminal symbol. So epsilon is not allowed here. But here the restriction is alpha, length of alpha must be less than or equal to length of beta. For example, AA tends to ABB. So here length of alpha is 2, length of beta is 3. Okay, always length of alpha should be less than or equal to length of beta. So here AA can be replaced by small terminal a, and variable a can be replaced by this one. The meaning is a, if you want to replace expand a, it should be preceded by the symbol a. So therefore it is called as context sensitive grammar. So if you want to replace here, if you want to replace s, simply s can be replaced by any one of its productions. We won't worry about the preceding or following symbols. But here in this example, a is preceded by small letter a, terminal a. So wherever a appears during the derivation, it can be replaced by ABB. For example, suppose assume that this is considered as a grammar. So S can be replaced by AA, and in this A is preceded by A. So the both symbol can be replaced by ABB in the next step. So ABB likewise. So this is called as context sensitive grammar, and the mathematical model that accepts this grammar is called as a linear bound automata, and language generated by this grammar is context sensitive language. Then the last one is the final one is type 0 grammar. This is unrestricted grammar. There is no restriction here. All the productions are in the form of alpha tends to beta, where alpha is one or more terminals or non-terminals, but beta means any number of terminals or non-terminals. So epsilon is also allowed. So here any number of terminals and non-terminals tends to any number of terminals and non-terminals, but left side at least it should contain one symbol. Okay, so then the machine, the mathematical model is Turing machine, and language generated by this grammar is recursively enumerable language. And as per Chomsky hierarchy, the inner circle represents type 3 grammar, then type 2, type 1, type 0. The meaning is all the regular grammars are also context free, but the reverse is not true. We cannot say all context free grammar or all context free grammar are regular. We cannot say like that. But all regular languages are context free language. Similarly, all context free languages are context sensitive language, and all context sensitive languages are unrestricted grammar. So these are the types of grammar. Thank you.